All right. Today we are going to talk about law of sines still. So just a quick recap from Friday. Remember, law of sines, don't get hung up on the letters. These could be triangles X, Y, Z. It does not matter that they are A, B, C. But make sure that you are matching the side across from the angle in the same proportion when you are using or setting up your ratios. Okay. Today it's titled ambiguous case, which sounds like a big scary word, but it goes to back in geometry. And we are not doing proofs, but there was a time in proofs that you guys proved that two triangles were congruent. And you had several ways of proving that two triangles were congruent. Side, 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 angle, side, angle, side, angle, 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 side, right? Yeah, well, we don't have to remember those. But there were two things that did not work. Not all combos of angles and sides work to guarantee that two triangles are congruent. Angle, angle, angle was one of them. If you knew three angles, it did not tell you that it was congruent to another triangle, because I can have an angle this small that's got all 60-degree angles, and an angle this, or a triangle this big that has all 60-degree angles. Those are not congruent, meaning equal or the same size. Okay. There was a second one that we really wanted to work, but it didn't. So side, 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 angle, side, angle, angle, side, angle, side, angle. Angle, side, side does not work to prove that two triangles are congruent. As much as we wanted to write that all over our math assignments, it's not actually a theorem to prove that two triangles are congruent. And what happens is you can actually get more than one triangle if that's the information that you have. And that's where we get this ambiguous case, is that we are not guaranteed a triangle, and we are not guaranteed just one triangle if they tell us an angle and two sides in the order of side, side, angle, or angle, side, side. So we get this thing called the ambiguous case, because this is what can happen. I have the exact same segment lengths here and here as I do here and here, and the exact same angle here, 39-degree angle, 41, 28, 39-degree angle, 40, and 28, and those triangles are clearly not congruent to each other, right? And so knowing angle, side, side does not mean that I have the same triangle here and here, and that's where we can potentially have more than one triangle given those three numbers. So when they ask us to solve the triangle, we actually could have more than one correct solution, more than one missing parts to those triangles. Now, if I look at the numbers they give me more closely, comparing the side lengths, comparing the adjacent side to the opposite side, and again, letters don't matter on this. It's where our angle is and what's across from it would be considered opposite. The other one would have to be adjacent to it. And if I were to compare those two, if the opposite side is longer than our adjacent, or as it turns out actually, or equal to our adjacent side, we can only have one triangle. Okay, it is not an option. There is no other ways that that can be drawn, because the length of the opposite side is longer than the length of the adjacent side. It's this unique time when the opposite side becomes less than the length of the adjacent side that we have more than one option, and we end up with actually three options. So then the options come from looking at the height of the triangle. So this dotted line here is not a side of this triangle, but is measuring the perpendicular height from that top vertex perpendicular to this side. And if I compare the height to the side across from our angle, if that opposite side is shorter than our height, we can't even make a triangle. Okay? If it's the same as our height, so our opposite side and our height are the exact same length, we get one and only one triangle, a right triangle. And we would find it like normal, like you did on Friday. But it's this case right here where our opposite side is longer than our height, that our opposite side could go that direction or this direction, and we actually end up with two possible triangles showing up. Okay, and so that's going to be unique from Friday, is that we would end up solving for two triangles instead of just the one that you were seeing before. So we keep talking about the height of the triangle, and that becomes part of our process today. I'm going to show you where we get this number, the height of our triangle. We're going to talk about it, but then we just are going to reference back to the formula that we get. If I draw in the height of the triangle and connect it to our angle and one of the sides they gave us, we get our little right triangle. And in a little right triangle, we can use SOHCAHTOA, right? So from this angle, height would be our opposite side, right? The adjacent would be the hypotenuse of the little red right triangle in there. And the SOHCAHTOA, the trig function that uses opposite and hypotenuse, is sine. So the sine of theta is our opposite over hypotenuse, or the height of our triangle, original triangle, over the adjacent side. And as we head through today, we're going to want to know what the height equals. So I would take this equation and solve for height. Well, to get height by itself, I would get rid of adjacent by multiplying both sides by adjacent. And we end up with the formula that the adjacent side times the sine of the angle equals the height of the triangle. I'm going to give you that formula again later today, but I wanted you to see that it's not just some random formula that you're just supposed to trust me, that's what it is. We could have gotten that every time, but we don't need to redevelop that every time. We just need to remember the height is going to be the adjacent side times the sine of our angle. Okay, so let's look closer at that time when we have a side-side angle. And guys, I cannot stress to you enough that you really only need this flowchart if that is the information given. You are told side-side angle. And so if that is the case, we are not guaranteed just one triangle. There could be more than one triangle, or there could be no triangles. So what do? We start by just comparing the opposite side to the adjacent side. And when we start that comparison, if the opposite side is greater than or equal to the adjacent side, it's automatically one triangle. Proceed like you did on Friday. But if we have that one case where the opposite side is less than the adjacent side, so here's how we follow a flow chart, that tells us then to find the height. And here's a little reminder of what that formula is we just figured out on the last page. The height of your triangle is going to equal the adjacent side times the sine of your angle. Once we have that, we go back again. Let's all focus on that opposite side. So we're going to compare the opposite side to the height, and there's one of three things that can happen. It can be bigger than the height, equal to the height, or less than the height, right? If it is bigger than the height, that means we have two triangles. If it is equal to the height, we have one triangle. And if it is less than the height, there are no triangles. Stop doing any work, move on. The little pictures at the bottom are just kind of to help you visualize what's going on, not something that you necessarily have to memorize. And the little star there that says adjacent is greater than opposite is greater than height, that might be something you just kind of focus on as far as, please understand that yes, I'm giving you this study tool. You do not get notes for your quiz on Monday, so at some point you're going to have to find a way to remember that one rare case that we have two triangles. And there it is. The adjacent side is bigger than the opposite is bigger than the height. This is how it looks in your book. So again, if we were to go back to our book, they show similar, not quite as the same, but very similar to what we just talked through. So I would maybe note to myself, if I were to look back at this page in my note sheets, this is the first 4 questions on your quiz on Monday. There you go, right here. Is asking you how many triangles can be formed with the given information. Now, the first thing you're going to do before jumping into a problem is you are going to answer this question for yourself. Based on the given information, is it a side-side angle question? When you answer that, if you say no, there is one triangle automatically. There's no work to be done. If you say that it is not a side-side angle situation, it's one triangle, no work. But if we say yes, then I have to think through that flow chart. That's when I have to start comparing my opposite to my adjacent and potentially my opposite to my height. Okay? Now, I think it is way easier to do all of these problems through a little bit of visualization. I draw all my triangles the same, so they're never drawn to scale by any means, and I always put the angle they give me in the bottom left-hand corner out of habit. But I've got triangle ABC. Okay? Angle A, they told me, is 73. Side A, which would be across from that, is 24. Side B, which would be across from vertex B, would be 28. And I can see in my picture that we have a side-side angle based on where those fall. Okay? So that tells me, first of all, answering this question, is it side-side angle? Yes, I need to think about my flow chart. The very top row of our flow chart says compare your opposite side to your adjacent side. Now, just to help us out here, our opposite side will be the same letter. This is always going to be your opposite side, right? That's how we name it, little a, is because it's opposite of angle A, which would make side B our adjacent side. And if I compare those two, the opposite side compared to the adjacent side, our opposite is 24. Our adjacent is 28. Well, 24 is less than 28. Therefore, the opposite is less than the adjacent. Okay, go to your flow chart. If it says the opposite is less than the adjacent, follow your flow chart. What do we do next? Find H, right? It says find H. So that's my next job. H equals, I use the formula that's on there, right? H equals the adjacent side, which is 28, times the sine of the angle, which is 73. That's just a number that my calculator is going to tell me. Grab your calculators. We'll build our way up there. Grab your calculators. Type in 28 sine of 73. This is a side length, so we're going to round to our nearest tenth. Jonathan, it sounds like you want to give me an answer on this. Okay. So again, we go to comparing our opposite to the height, right? Our opposite is still 24. Now our height is 26.8, and I go to my flow chart and find where it says the opposite is less than the height. Remember, that means the opposite is not connecting down to our triangle if it's less than the height. So there are no triangles. Now that's all it's asking us on this. We wouldn't have had to do any more work, but if that were our answer anyway, we would stop. There is no more work to do. There's nothing to find. It's not a triangle. Any questions on that? Okay, let's look at the next one. Again, I would start by drawing myself a picture of what's going on. Angle C is 70 degrees. Little c, which is across from that, is 27 degrees, or 27, whatever units that is. Okay. And we go through the whole question, is it side-side angle or not? Based on where those fall, is that side-side angle? Yes. Okay. So that means we start comparing. C would be our opposite. B would be the adjacent. So I compare the opposite to the adjacent. And we go to our flow chart. The opposite is less than the adjacent. Again, we already talked about this one, right? If the opposite is less than the adjacent, my flow chart leads me to find H. So H is the adjacent times the sine of our angle. Okay. Dylan, when you got that typed in, I'll take the height from you. No, thank you. Comparing those, opposite is greater than our height, right? And so we go to our flow chart. And on our flow chart, Michael, what did it say? Opposite greater than height, how many triangles? 2. Okay. Now, here's what happens is we start doing the work today, and I'm going to add a bonus one on here because we just start going through the motions and being robots, and we forget the first question. If I had given us the information that, like, A equals 50 degrees, B equals 10, and C equals 12, okay, and we start comparing our sides and stuff. Again, if I draw that picture for myself, that means I'd have a 10 here and a 12 here. Don't forget the first question. Is that a side-side angle? No, that is a side angle side. There is only one and only one triangle that can come from that piece of information. I don't have to do any of this. My answer is one triangle. No work, no comparing, no nothing. So don't get into the like flow chart. I have to do that on every problem. If it's not a side-side angle, you don't have to do that. It's one triangle. Go find it. Okay? But we're going to focus on the side-side angle today. So the first two questions you are going to see today, notice the directions leave it open. They do not guide us. It says find all solutions if possible. Okay, well, the if possible means there might not be a solution, so there could be 0 triangles. all solutions goes to the fact that there could be one triangle or there could be two. So that's our first job, is find out how many triangles we have. If no solution, write no solution. And then the last part just goes for this entire section. Round side lengths to the nearest tenth, angles to the nearest degree. That is never going to change. Draw yourself a picture of the information. A is 63 degrees. Little a is 18. B is 25. And I ask myself, is this a side-side angle? Yes. So that's where we go start comparing our opposite to our adjacent. Opposite being 18, adjacent is 25. And again, we see our opposite is less than adjacent, right? Questions so far? Kind of speeding up that first part here. Okay, if our opposite's less than our adjacent, that is what we've continued to see on all of these, right? Opposite less than adjacent, the next step we went to is finding the height of the triangle. So let's go to our height. Height is the adjacent side times the sine of the angle. How am I supposed to remember that formula? Practice. We're going to practice that, and remember, you can develop it from that right triangle if we needed to, but we're going to have to practice it. Okay? Go ahead and grab your calculators, get that typed in. It's 22. And comparing those, and I see that the opposite is less than the height. If the opposite is less than the height, what does that tell me? No triangles. Direction said if we don't have a triangle to write no solution. So that is exactly what I will write. No solution. Done. Move on. Okay, so we'll look at one that has a solution then. Same directions. Again, start by drawing yourself a picture of what's going on. And like I said, I draw mine the same way, so I know that it says it's a 105-degree angle. If it bothers you that I don't draw that to scale, you can draw yours to scale, that's fine. I just draw it so that I can see where things are in relationship to the others. Okay, so I've got a 105 here. Across from it is 73. You will notice that my other two letters will change. I typically draw mine so it goes this way, so I put the letter here that's going to put my side here. It doesn't have to. Just make sure that you're careful about matching up the right letters when you go to write your answers, okay? So let's compare real quick. Opposite to adjacent, 73 to 55. Our opposite is bigger than our adjacent. Go to your flow chart. It says one triangle. Okay. To find our one triangle, we then are finding what is missing. So we, at the end of this, will have an angle B, an angle C, and a side C. That is our unknowns, right? If I go back to our picture, that's what we don't have up there. So this takes us back to Friday, and how do I go through finding those? So remember to use law of sines, that the key component to law of sines is knowing that side across from an angle. And so that's where we always start our base, right? Sine of 105 over 73. The only other piece of information we have is side B, which means we have to go find angle B. So let's start there. Angle B is where we're going to be starting. Use your base. Sine of 105 over 73 equals sine of B over the only other thing we know, 55. Okay, hopefully we practiced that enough on Friday, but go ahead and grab your calculators. You're going to do your cross multiply to solve. We are finding an angle, so at some point on this one we're going to have to do inverse, right? That's how we find an angle, is use our inverse sign. If you're forgetting how that is, I'm going to do the algebra steps up here. If you remember how to kind of just jump to the end and to get it typed in your calculator, get it typed in your calculator. I would start with our cross multiply. 55 sine of 105 equals 73 sine of B. Divide by 73 to get the sine of B by itself. And then I need to get rid of that sign because I want it at the end to say B equals, right? And so when we get that sign out of there, when I move it to the other side, it is inverse. That's how we solve for an angle. And type all of that in. 55 sine of 105 over 73. Okay, well 55 is smaller than 73, so I'm going to expect an angle smaller than 105. Plus, you can't have two obtuse angles in a triangle, right? Okay. When I have a table that agrees on an answer, what do we get? 47? And it's an angle, right? So we are rounding because I think it was like 46 point something, right? So we're rounding to our nearest whole number because it's an angle. So that just gave us this angle right here, right? 47 degrees across from our 55. And then we have to go back to, it's a triangle. So to find C, 180 minus the two angles we know, 47 and 105. Gavin, what's C? 180 minus 47 minus 105. Okay. And again, stick with that hinge, right? 105 and 73, those are unrounded, those are across from each other. They gave them directly to us, so I'm going to use that for everything. Sine of 105 over 73 equals, and then we just found the angle across from side C, sine of 28 over C. Do your cross multiply. No inverse on this one because it is a side length. It is a side length, so we're going to round to our nearest tenth. Jared, when you got that typed in. .28, so while he's typing that in, remember 28 is our smallest angle. I would expect something, our shortest side. Very good. Right? I would expect something smaller than those because that's our smallest angle. Any questions? Okay, so that's just a good reminder of what we did Friday. That was no different. Okay, we do need to see some that have two angles. So how do we get two angles? We go to our flow chart. Our opposite was less than our adjacent. It told us to go find our height. I did. And then my opposite was bigger than my height, which means that we're going to get two triangles. So here's how those two triangles come into play. And I know this is kind of a confusing picture. But what happens is that opposite side, it could be drawn this way. And if it is, I get this big green triangle. Okay? But the opposite side could also be drawn this way. And if it was, I would have gotten that skinnier blue triangle, right? So those are the two different triangles that come about. But what happens is, if I were to look at those two opposite sides, we get the red triangle, which is made up of an opposite and an opposite. So that takes us back to geometry. You remember that, what that's called? Two triangles. Those symbols are congruent. If we have two congruent sides, it's called isosceles. Okay? If we have an isosceles triangle, one of the things that was true about it, and this is not things you need to remember, but it's where this is all coming from. Isosceles triangles have congruent base angles. Okay? And so what happens is, whatever angle this is the same as it is over here. Great. This is the angle that when we do our inverse sine, it will give us every time, because inverse sine has a limitation. Remember, it's got a domain restriction on it, right? And the limitation is it can only ever give us an acute angle. And so it'll always give us that one first. What that means is whatever it gives us will be the same as this angle. Great. And those two have a relationship. They are a linear pair. And so once we find that initial angle, we will always find its linear pair, because that would give us the angle in the blue triangle. Okay, that is the absolute key to finding both your triangles. Notice the difference in our directions at the top here. On this one it says find two triangles. What that means to you is we do not have to do that work at the beginning of comparing your opposite to your adjacent and your opposite to your height. They are already telling us that it falls into what we need to happen to have two triangles. So we've got triangle with the angle A being 45, side A is 18, side C is 24. Now, let's say this was on the problems before, we would have compared our opposite to our adjacent and seen that our opposite was less than our adjacent. So I would have found the height of this. And it turns out I think the height comes out to 17, and our opposite would have been greater than our height. It did not ask us to do that, which is why I just kind of did it off to the side. But you would see that it would tell us two triangles. So when it tells us two triangles, we're going to go find our two triangles. We have triangle number 1, whose missing information is angle C, angle B, side B. We have a second triangle who's missing the same things. Now, to keep the difference between these two, they will mark the second one as C prime. That's just to say that it's not the same angle C. It's from the second triangle, possibility. B prime and side B prime, okay? We start our process like normal. We find that angle across from the side that is in our picture. We set that up to help us find the angle across from the side that they gave us. So I know that the sine of 45 over 18 has to equal the sine of our unknown angle C across from side C, which is 24. Okay, grab your calculators, find me angle C, please. When you are doing this, just like our first example, you will have to use inverse sine. Inverse sine is only defined in quadrants 1 and 4. Because of that, think about the angles that are in quadrant 1. 30, 45, 60, right? Small angles, they're all acute. That is why it will always give us the acute angle first. What is, did I talk long enough? Has anyone found C yet? 71? Okay. Because of the limitations, it'll never be able to give us that obtuse angle that we saw in the skinnier blue triangle. So we have to go find that. Here is the absolute key to this entire thing. Immediately go find its linear pair. Okay? So as soon as we find that, we are going to take 180 minus the angle you just got. Because they are a linear pair, or supplementary, however you want to think about it. It doesn't matter why. You need to remember that to get into the second triangle, the first one you find, you take its linear pair. So 180 minus 71, we get an angle of 109. This right here is your key. To start the second triangle, 180 minus the first angle you get. Okay? Then guys, it's no different. We basically have two problems. Finish this one, go finish that one, right? Right here, we have that we just got an angle of 71. Okay, well then to find the third one, 180 minus 71 minus 45 gives us what? 50 what? 64? So close. Okay, and then find your last side. Again, this is going to be used throughout every proportion in our entire problem. Sine of 45 over 18, that's not changing. Finding our side length here, go ahead and round to your nearest tenth. Should be somewhere between 24 and 18. And if you're not getting an answer between 24 and 18, something's up. 23? 22.8? Yeah, we'll round to our nearest tenth. 22.8? Good? Okay. Now, here's what confuses people. Remember that in triangle 2, what we started with, was this information. A 45-degree angle, a side of 18, and a side of 24. Guys, that is not changing. That is still true. What's different is on this one, we got angle C to be 109 degrees instead of 71 degrees. Okay? But now we just proceed like normal. So I've got a 45 and a 109. Subtract from 180 to find your third angle. Now this one's not too ridiculous. It's what, 54, 26? Okay, that's not, but there are times that this is going to be a really small angle, and that's okay. It's a really skinny triangle usually. So a small angle is to be expected, like really small, like 9 degrees or something can happen there, okay? And then continue. Again, that sine of 45 over 18, that is still true in this triangle, right? That is not changing, so we continue to use that this whole time. And now I just got, what, a 26-degree angle up here. Use that to help you find side B, sine of 26 over B prime. Cross multiply to solve. Now 26 is quite a bit smaller. I would expect something quite a bit smaller than 18, 11.1, okay? What would if I had like actually drawn it to scale? Is that what you're saying? Yeah. So the obtuse angle, this one would have looked like a 45-degree angle would have been this way, and the 109 would have been like one right here. And you would have had your 18 here and your 24 here. Compared to this guy, which would have had that 45-degree angle here, the 24, and our 18 would have swung this way. And what was it? A 71-degree angle would have been here. Yeah. So hard to picture when I draw them all identical, I get, but questions on that? Okay. You're going to try to work ahead of me on this one. Try without me prompting you. Can you get that second triangle started? Okay. It does directly tell you there are two triangles. You do not need to look at your flow chart. You know there are two triangles. Go find them. If you're solving for an angle, yes. Anytime you're solving for an angle, unless you're subtracting 180, obviously. But if you're solving for an angle, you inverse sine. Until tomorrow. I mean Wednesday. You have till Wednesday. If nothing else, you can draw yourself a picture of what's going on, label it triangle ABC, get your information in there so you can at least see what you're missing. Start by finding your missing angle. You're going to be missing an angle. It's a side-side angle problem. Set up your proportion. You can at least get triangle 1 done. Okay, we are doing a law of sines problem. The key is going to be to find the angle across from the side. Use that to start your proportion. The angle we have across from the side would be 24 degrees across from a side of 13. That's going to be in every proportion we set up. Based on the given information, the very first angle we will solve for is angle B. We have side B. Leads us to solving for angle B. Because we are solving for an angle, you needed to use inverse sine on your calculator at some point. It is an angle, so we're going to round to our nearest degree. Do I have a table that both has that agreed on? Very first angle. Should be something not, I was going to say, should be something not too far off because our sides are not too bad here. 28 degrees. Again, inverse sine has its restrictions, and so it's always going to give us the acute version of that angle. And the very first thing I will always do is find its linear pair. Subtract from 180. 180 minus 28 would be what? 152. Okay, that is your key. If you forget this step right here, you will not be able to get triangle 2. Linear pair, do it immediately. Find your first angle, subtract from 180, start your second triangle. Okay. You can continue with the second triangle or go back and finish this one. So if I go back and finish this one, 180 minus 28 minus 24. Let's see, what is that? 60, 40, what is it? And again, this part of your ratio will not change this entire problem. So I will always go back to the sine of 24 over 13. And this one should be way bigger. It's our biggest angle. Who's got C for me? $25? Is that rounded to the nearest tenth? 25.2? Okay. Okay, so then finish out triangle 2. 180 minus 152, and this is the one I was talking about. Remember, minus 24. 24 is still in our triangle up here, right? We found angle B is 152. It can be a very small angle. If you subtract those from 180, how big is this angle? 4 degrees. That's a tiny angle. Okay, I get that, which means the side across from it is probably going to be really small as well. And we continue to use this angle across from this side in all of our proportions. So the sine of 24 over 13 equals the sine of 4 degrees over our last side, which also should be a much smaller side. Who's got that for me? Yeah, 2.2. Okay. Guys, I don't need a lot of work on this. Here's what I do want to see. Okay, I don't need to see this. That does not need to be written anywhere. If you like putting that on there, go ahead. I need to see a setup of some sort on your law of sines. Okay, so give me a setup. If you like showing more of the solving, great. If you can do the setup and go to your calculator, go to your calculator. I don't need to see the work, but if you want to show it, that's fine. But you got to give me something. A list of answers is not quite enough. So make sure you're giving me some setups of how did I get these in here, and that's really all I need to see. Okay? Your assignment is out of the book, and I will continue to remind you guys, this is a do I know how to use my calculator type of quiz, and that is half of the question. You guys have to be actually typing this in your calculators, and knowing how to do this.